to see if there's a COVID COPE survey insights. I mentioned that because when we started the program, we never thought that we were going to have to do a real-time eligibility criteria based off of whether a participant was going to be affected by the pandemic. So I think there's an earlier question about the consent process for another study. This consent process that we have, it took about 6 months to develop with a whole bunch of people in different states. But in effect, every participant has to review both a video of the salient points of the consent and sign the consent form. The goal of the project isn't to convince people to join, it's to convince people to understand what they're joining and why, and make them want to continue to join. There are a lot of places where we've had to improve this over time, but in this process, by the time it's done, participants will basically be told all of the risks in a way that startles many of them. One of the key questions in this is whether or not participants understand that every technical system that's out there could be attacked by hackers. And so rather than pretend like we have the most secure system ever, we have a pretty secure system. One of the questions basically makes it clear to participants that in participating in this research, you are giving data that matters to you and probably matters to somebody else. So there are a range of survey modules that have been developed by a whole bunch of other partners that don't actually work in my company. But the goal for these surveys is to collect a whole bunch of data that can help classify the biosamples that are collected by this program. So at this point, every participant who has provided a blood or saliva sample, which is going to be sequenced, they've also provided a fair amount of metadata about the diseases they've had, about their medical history, about their family medical history. And recently we released a social determinants of health module as well. So I think this is one of those areas where a tool that we started on Radarbase a long time ago ended up finding its way into some of the work we're doing here. We author all of our questionnaires in REDCap, but we can't use REDCap to display the surveys back to participants, as I'm sure in a technical decision. I like the nodding because I remember when those decisions were made. That same practice is what we're doing here in the Vibrant Health System, where basically we author the survey in REDCap, and then we do have to do some tweaking of the visuals of that survey once it's actually in the platform, because to make a really engaging experience, you can't just provide people with a paper measure turned into a phone app. You actually have to make it look fun. And then, as a note, all of this data, whenever it's sent to our central repository, is sent in a FHIR format. If anybody has any questions about that, that's one of the areas where I have more technical expertise. And just note, not all data in this program is transmitted using FHIR, but wherever possible it is. So at a high level, whenever we're creating a human interaction, we try to write a codebook that's somewhat FHIR compatible, because then a whole bunch of other systems can make use of it. I should also note, so since one of the primary goals of the program is to collect biosamples, one of the things that we need to do is to provide a mechanism for participants to find an ideal way to contribute that biosample. This could mean going to a hospital or to a blood bank in your area, but during the pandemic, that was a little bit trickier. So what we've done since then is we've built a range of tools that allow for participants to contribute remotely. So we will send saliva kits out to them. Soon we'll be also allowing people to schedule in-home visits. But while our team doesn't do the facilitation of the actual collection, we do develop the tools that allow for our systems to engage with participants to either come on site or, in some cases, have a kit shipped to them. So this is one of those areas where I think there's a difference in the way we approach it, just because of the kind of projects that we're working on. We don't have researchers that are authorizing access to Fitbit data on behalf of participants. All participants actually have to share their data directly. So earlier there was a question about the iOS device for passive sensing. We do collect Apple Watch data, and we do collect the EHR and HealthKit data, but the character of that data is very different than the character of the Fitbit data. I should note that in all these cases, basically, you're encouraging participants to go in, log into another platform, put their username and password in, and then accept a whole bunch of data to be shared with the program. This process is pretty similar, whether it's EHR data or Fitbit data or Apple Watch data. So one of the challenges here is, my parents are in their early 70s, and my dad was sick recently, and he needed to get into his electronic medical record from home. He didn't remember his password. It took me a good 30 minutes to figure out how to give him access to that password. This is the same process that we're asking everybody in this project to use in order to share their Fitbit data. So if you're part of a population for which that's easy, that's not a big ask. But if you're part of a population where that is trickier, it's the difference between getting no data and getting all of the data. And given that we're asking participants, in some cases, to do it multiple times, it's a major sticking point. I think this is another area where I learned this here first, and I've learned it even worse at larger scale. The quality of the backend infrastructure from other vendors like Fitbit is sometimes not good.
Can you hold it?
Oh, sir? Sorry about that. So there are a lot of situations where when you're trying to access data from one of these partners, it'll just fail silently, and you'll have to figure out later why it broke. It's also the case that they make improvements all the time, and while an older version of an API will still work, there will be a new API that has much better data. I'll also note that there are situations where the latency between the device itself and the cloud can be pretty significant, to the point where you may think that it's entirely broken. And I think this is the question for later. Because of the size of the program at the moment, we're not providing the raw data to researchers. That would be way too much data, and we don't have the tools to do it. But I think this is one of those areas where there's a lot of room for exploration, and as data becomes less costly both to use and to analyze, there are opportunities to develop better features. And so it's a really get a little bit and say it would be great if we could also develop a schema for those features and not just for the data. So I'm going to do this kind of quickly. We also collect physical measurement data. Again, this is just more data that can characterize the individual. And we also share EHR data. So again, I don't have a strong sense of how the UK EHR system is working compared to the way this works in the US. But in the United States, the vendor of your EHR has one amount of control on your health record. The region has rules related to how you share your health record. There are rules that are making that easier and make it possible to share the data more quickly. But as it stands, to get access to your own medical record may be very difficult, even for a large program like this one. So we allow for participants to share EHR records in more than 5 or 6 different ways at this point, which if people are interested, I can show them that later. And we try to maintain the premise that if we've collected it from you, we should provide it back to you. I always forget that those are actually my measurements on the screen, and so I've at least lost some weight since then. It's also one of the lessons learned. We do allow for participants to compare their responses to the responses of other participants. But this can get really tricky if you're part of a population that is of lower representation, because you may find that there are ways to characterize this data that paint an unfavorable picture and a very limited, skewed picture. So we've had to remove some of the comparison features simply because it doesn't tell the full story. And then I mentioned earlier, most of the complex work we've done recently is to develop these tools that allow for researchers who are doing the engagements with participants, and I'm talking more like the research coordination staff more than the actual researchers analyzing the data, to do things like track their completion of key activities so that they can do things like develop email campaigns and market campaigns to help participants complete tasks. And that does allow for us to do things like figure out what part of our population has not been adequately recruited or represented. And a whole bunch of tools that, it's funny, whether it's scheduling your phone to run specific assessments at certain times or scheduling appointments, scheduling seems to be the one thing that is hard all over the place. But our tool allows you to schedule appointments, as well as scheduling interactions with questionnaires and surveys. So that said, I've learned the hard way, both in early radar projects and also this one, that there's not one way to support the kind of work that we're doing. Our work is complementary. And I'll also point, I know this is kind of an undercurrent of what I'm saying, but the long-term engagement of participants requires a range of strategies and tooling. The kind of things we're doing for large cohorts may not be the same that medium cohorts need, but there's a lot of overlap there. And last thing, we've been doing this for about 10 years, so if you have any questions, I can probably tell you a way in which we have done something successfully and unsuccessfully in the last 5 or 6 years. That's basically it. Point in time.
We get about 2 minutes.
Any questions?
Thank you. Really enjoyable talk. You talked several times about maintaining engagement of the participants, but I don't think we saw what people have to do longitudinally. So what are you asking of them repeatedly through time? And then the second part of the question is, what have you learned about what are the best ways to get people to come back and fill in repeat surveys or other things that you're asking them to do?
So the first thing I'll say is that as the team building the technologies that support this, what I'm about to say is more a representation of the teams that have made those decisions more than my company or the work that I do. So most of what the Albus Research Program asks participants to do is a one-time task, but we do it infrequently. So when you first join, you complete 3 to 6 surveys, and we ask participants, when they're eligible to do so, to either come into a site, provide samples or not. And then we have these little modules called snap questions that we send out periodically to try to maintain engagement. As the program progresses, there are more and more opportunities for participants to engage. So when it started, there were basically 10 surveys and biosample collection. We're moving into a world in the next couple of years where we'll be releasing a new data collection experience probably once a quarter, once every half year. That's partially because when you're trying to get this large cohort of moving, we wanted to keep the demands of participants pretty low. At the moment, until later this year, we're not asking participants to do things frequently or in a repeated way, but starting later this year, we'll be trying to do something like that. I think that's one of those activities that is trickier to do in a large cohort than maybe just a small one. In terms of engagement, I'll say, we support the partners that do engagement, and so it really depends on the prospective participant, who in some cases may be a patient at an institution, in some cases may have no relationship to an institution. I think we'll go back to that slide. So later on. So because we're supporting participants all over the place, we've developed tools that allow for you to do basically every type of technical engagement you can think of. So we can do push notifications on phones, we can do SMS notifications, we can do email campaigns. There's literally in the program a truck that drives through the United States trying to drum up participant engagement. Each of the individual healthcare providing organizations that engages the participants has their own local or regional campaign. And the pandemic had a pretty major impact on what people thought best practices were. And so I will say before the pandemic, a lot of traditional engagement techniques where clinic recruitment, regional marketing campaigns were the primary ways to keep people engaged or to recruit them. Since the pandemic, it's really shifted more towards a model where we are trying to give people meaningful content independently of the portal they have to log into. So every month they get kind of a digest of interesting things the program has been doing or interesting things in the field. As you can probably imagine, there's a pretty high attrition rate, but there's this smaller cohort in the project of people that are heavily committed and heavily engaged. I didn't prepare that presentation, but if you have interest, I can show you some of that later.
Any other questions?
You might have mentioned this, Mark, but I might have missed it. Did you look at which kind of, type of people maybe engaged more, engaged for longer? Have you broken this down at all to understand your population?
At this point, the question is, in what ways have we not broken it down? The short answer is yes. We actually have an entire set of dashboards that will break down engagement by all the normal demographic criteria, but also by things like your disease history, and also by things like your usage of the system. I can show you some of those tools later. There's some really cool tools there, but because of how big the study is, how big the project is, the findings end up being kind of all over the place. There are a lot of places where one strategy seems to work and one type of population seems to be highly engaged, but in another area, it's not. There's a lot of data here for people to analyze, I guess is the short answer, and a lot of tools that we have that enable it. I'll be here tomorrow. If you want, I can show you some of the more kind of engaging findings that are there.
Okay, yeah, very cool to see all these systems. I'm wondering about, you were talking about FHIR and using EHR data, and was wondering because in FHIR you can specify the ontology with each measurement.
Yeah.
How you kind of harmonize the data from different ontologies?
So there are 3 answers to that question. The first one is I don't, but there's this whole team that does it. Well, I'm saying I Julia to give me the face. No, that's good. There's a whole team that does that kind of work, and what they're still in the progress of us doing it. But when you're collecting that data, we try to make sure in advance that it has the existing linkages to the vocabularies that matter. for the survey questions, for example, because they're authored by our program, the survey creation teams have made sure that any of the survey constructs that tie to known codes are tied to all of the vocabularies that exist related to those codes. In terms of harmonization, there's a really cool querying tool that you can get access to if you're a researcher that's certified to access the data through the program. I can probably show that to you later. There's a complete analysis interface that's provided by a different partner, and there's a data browser that lets you go through the ontologies. I'm not sure which vocabularies you're familiar with. There's LOINC and SNOMED, and most of that is basically baked into it. And there are cases where we have concepts that don't exist in those vocabularies, and so we kind of coin our own, but wherever possible, we try to link it back.
Right. So in the end data, the researchers still have access to those different codes and different ontologies. Yeah. Okay. Cool.
At least where they persisted and haven't been curated out.
You mentioned that you didn't just want to do a digital version of paper questionnaires. How creative have you got in surfacing new types of ways of collecting information from the participants?
There are a lot of answers to that question. The first one is I'll use the example of a mood questionnaire that we had intended to launch before the pandemic. We were actually doing a more kind of graphical face version of that data collection tool. But mostly they're closer to paper surveys in that they're assessing question constructs, and some of the UI is closer to kind of a traditional UI, but I'll give you some other better examples. Some of it is more kind of gamified. We have a new tool coming out in, I think, 3 or 4 months that is going to be 6 or 7 cognitive behavioral tasks that are more like Stroop tests and brain testing kind of tasks than actual surveys. But the long of it is that we've stayed closer to traditional models for the beginning of the program, and what you'll see probably in the next couple of years is there's a roadmap that's still being worked on, but the next years have about 8 non-traditional survey measures. I can give you a couple of them that are all in public domain if you're interested later. So some do hew closer to the traditional survey.
And have you found greater engagement with those where you've had gamification?
So we're just getting into it, and in the places where we have put them out there, it's a little bit inconclusive for all sorts of different reasons. But I think it was the belief that those kinds of methods would improve engagement, but you also have to get people in to do it in order for them to be engaged. For what it's worth, I think that's the harder part, getting them to come back.
I had a quick one. So you mentioned the data itself is able to people from universities. What's the process around that? How it works?
So at the present date, the researcher community is made up of US-based academic research institutions and nonprofits that sign a very rigid agreement with the NIH. But there is a roadmap specifically to extend that to other regions, specifically the UK. If you have interest, I think they're looking for people to be pilot partners. So if you can give me your name, I can actually forward that onto the teams that are looking to expand into those groups for the next area of the roadmap.
Yeah, I think we would hopefully because probably in just any other questions? Thanks.
With camera on. Okay, maybe while we wait, I'm gonna explain the voting and using of the active RMT arm of the database platform. So you already received instructions a few days ago on how to download and scan a QR code and then do the voting for the best poster and the best lightning talk. We will send you soon a new email with the instructions again, and now including the QR code. So please download the app, scan the QR code. The QR codes are also hanging in the screens and on poles in paper printed, so you can scan it directly with your phone. It's a nice way to try the application and also then vote for your favorite poster and lightning talk. We will be awarding prizes at the end of today's program, so please check the posters. They are also online. You will also receive a link for that. And just check out the app and vote. We will send you the email soon. Oh, and I think we are now ready. I don't know. Yeah. I'm going to try to remove this, and I think we can. Can you hear? Oh, he can hear us, but we cannot hear. No. Let me check. Can you hear us? No.
So I'm trying to swap between the online speaker and
I can hear.
session speaker.
We are there, but we cannot hear.
Do we need to turn off?
Yeah, we cannot hear you. Slack.
Okay, so you can't hear.
It's his Slack. Oh. Yeah, no.
Yeah, if you could just ask him for unmute, because this isn't it.
He can hear us, but
It's Slack in
yeah.
Hello?
So,
He's gonna try a different one.
I'm going to try and connect again.
Yeah.
Hey guys, can you hear me now? Cool. Do not know what happened then, but anyway.
We cannot see your screen though now.
Now you can see my screen too?
Not yet. Yeah, now yes.
No, yes. Okay, cool. Sorry about that, everyone. Not quite sure what happened there, but anyway, we can hear and see everyone now. So, yeah, I'll get started and try to be as quick as I can. So, what I want to talk to everyone today is about maybe one of the more novel signals that's collected in radar base being voice signals. And maybe a lot of you in the room aren't that familiar with why we might actually be collecting voice signals as something to use in health research. And the reason we do this is that speech production is remarkably complex. We're combining cognitive elements around what we want to say and obviously the muscle commands and things needed to say it in with this really coordinated set of muscle movements to create very small individual speech sounds at a rate of 20 to 30 milliseconds. So as health comes in over the top of all of this, it starts to change and interrupt this signal So we can see a lot of different health effects coming in when someone's physical or mental state changes. Cognitive impairments start to affect this sort of muscle formation, neuromuscular commands. Mental health challenges a lot of these different areas, and muscle impairments come in, and the speech just somehow differs from its normal state. And this then allows us to do some statistical analytics, some machine learning on it, and start to use speech as this sort of marker of health. And I'm just going to very quickly present 2 results from the Radar CNS study, just to show some of the difference in some of the things we can actually get with speech. So using the depression arm of the Radar CNS study, we collected speech via the ARMT app for a period of almost 2 years, where someone did a speech activity every 2 months, where they read a transcript of a poem, or they answered the question, tell us something you're looking forward to, every week. And we were particularly interested to collect speech with depression because we knew there's a lot of things that change, like the pausing, the cleanliness of the speech, all sort of change with increasing levels of depression, but nobody had looked at this in long-term studies, and this is what the Radar MDD study and the use of Radar Base allowed us to do, is collect one of the largest, or the largest longitudinal data set available. We collected just over 60 hours of speech, with the majority of it coming from the UK, and that's mainly because we had more participants in the UK. We expected to get sort of more speech through here. And then using that, we were then able to start to look at a lot of different speech features relating to temporal aspects of speech and how these change over the course of a longitudinal study. And what we found is that across 3 different language cohorts, that people spoke slower, and their articulation rate, so their actual forming of each individual speech sounds, was slower. And this is consistent over different languages. And this is really cool result, because this was the first time this had been seen in a big longitudinal study in 3 languages. So it's quite a powerful finding we were able to get. One thing we did find was that pausing wasn't actually that important, which is interesting, as a lot of other studies said that it was. But using Radar Base, we were able to collect so much information about the people and control for so many factors. This could be one of the reasons why pausing was not a significant finding. So is that a question then?
No, Siri.
Okay, no problems.
Here's the App Store.
So yeah, we were able to find some really cool, interesting timing results. We were also able to look at depression in terms of things such as the pitch, the sort of liveliness they speak with, and the loudness they speak with, and a few other factors relating to the quality of the speech sound. And what we did find, again, across all the 3 different languages we tested, was that people with a higher level of depression spoke more quietly. So this was a significant finding, again, in each of the studies. We were also able to see some effects relating to the quality of the speech sound. So what's generally happening is we think that the speech sound with increasing levels of depression gets a little bit more of a sort of hoarseness to it. But we didn't see this so much within the Spanish speech, mainly within the Dutch and the English speaking cohort. And finally, we're able to test sort of vocal tract coordination by using what are known as formant features, which are markers of sort of where we're holding the vocal tract at one particular point of time. And again, we're able to find that there are some information within this relating to depression. The findings weren't as strong, but these are very complex features to extract. And I did them in a bit of I just took a mean over the sort of a course of a whole sort of sentence, instead of looking at individual speech sounds and sort of figuring it out more fine-tunedly. So I think when I do some extra analysis in on this data, I'm going to find some very interesting findings, but I need to dig deeper here. So yeah, using Radar Base, using speech, we're able to get some really first-time findings within the depression literature. It was the first time we were able to do a cross-culture comparison between people with depression speaking in different cultures in different languages. And what we found, speech rate, articulation rate, and intensity were affected by depression. We also saw that number of pauses wasn't as affected by depression. The other thing that I didn't speak a bit too much about was that speech features differ between the two different tasks. If someone's doing a reading task or someone's doing a free speech task. And the reason for the differences between here is the acoustic information being collected is different, which is going to create some slightly different findings. So we're also able to get some results from the Radar MS study. And I would just want to use this study to highlight that speech can be used as a marker of a lot of different conditions. So it was a little bit more experimental in the MS study. We know that dysarthria, this sort of hoarseness tone, slurry quality with speech is important with people with more severe cases of MS, but in a sort of general population of people with early diagnosis or with relapsing remitting MS, we didn't quite know what speech effects we were looking for. So the speech task was slightly different. They did it less in the MS study, so we collected a little less data. And we also collected different scores, so looking at the expanded disability scale, looking at a particular item within that scale, focusing on problems with speech and swallowing. And we also looked at the fatigue severity scale. So trying to essentially present some results here, measuring either disability or fatigue and looking at different factors coming through in MS. So we weren't able to collect as much data in the MS study, but it was a smaller scale study compared to the depression study. We were still able to collect almost 25 hours of speech. So again, one of the largest data sets of its kind, especially when you consider we did this across 3 countries, 3 different clinical centers as well. So there's a lot of information on the screen, but I'm just going to try and break it down. And just so this is within the Italian data, what we see when we look at disability is that the vocal tract information is particularly important. There's something coming through there that where the majority of the changes we found were. When we go into specific difficulties with speech and swallowing, again, vocal tract changes were important, but we also find the quality of the speech changes. So this relates to that dysarthric quality coming through in higher levels of MS. And again, when we moved to fatigue, one thing we did find was that intensity. So again, people with high levels of fatigue spoke a bit quieter. So you can start to see how different things can be measured using speech scales, and that's using speech as a measure, and that's one of the really cool reasons for including it in studies, and one of the things that Radar-Base really sort of opens up. We were able to see a sort of similar effect across the other studies, but not as powerful, where we sort of see these differences in articulatory effects, difference with the disability, and differences in prosodic, or differences in that sort of melody, lifelessness of speech, looking at the FSS scale. And yeah, it's just really highlighting this. And again, able to see the same in the Spanish data, these different effects coming through when we look at a different sort of property, different speech properties, and how we're able to get this information. And of course, one of the challenges is how do we then start to pull apart and disassemble all this sort of information that's coming through in speech signals. So there's evidence from the MS study that speech relates to 3 different scores tested. Articulatory features were a more promising marker of EDSS. Phonetic and prosodic features more strongly associated with brainstem functioning, particularly in the Italian data, and prosodic markers, particularly intensity with fatigue. But we need to explore, and we need to try to break down this complex relationship further, pushing into some more advanced analytics, especially taking speech forward, sort of using deep learning in there. So just to round out very quickly, sorry it's been a bit whistle stop here, I just want to speak a little bit more about participant experiences, because there's one thing for me to analyze the speech, but the other thing is we need to collect speech from people, and it is a bit different. Our voices are uniquely ours. The content of speech can be highly personal, highly emotional. There needed to be a little bit extra technical literacy to collect the speech through Radar-Base. People have to press a start and a stop recording. They have to know a little bit more about what's going on. We ask them to be aware of the environment they're in when they're doing their recording. So motivation is a big factor in speech-specific research. So we ran a speech study, a sort of participant survey through our speech cohort, and we've had time to do a go through of all the depression scores and the depression cohort and look at some of this and some of the different factors. And what we found was that between these 2 speech tasks, sort of reading a poem or telling us something you're looking forward to, people were definitely more comfortable reading a poem. And while this sounds not a particularly, oh yeah, I expected that sort of finding, but no one has actually looked at this in speech research. And again, Redarbase offers so many tools to allow us to collect such a wide range and richness of information there. What we also did find is that with increasing comfort with a task, we do get more speech. So if you're happier doing it, we get some sort of more speech. It's a sort of a small and moderate correlation. But again, this idea of comfort needs to sort of come through and be designed, and is a lot of focus of our future studies. We also asked people about barriers they were looking forward to, not seeing barriers that prevented them from recording their speech, sorry. Not seeing notifications was one of our biggest barriers. Low mood, forgetfulness, and feeling tired, so things associated with depression were also other barriers. Very interesting was that privacy concerns were not actually a big barrier in our cohort towards recording a speech, so that was particularly good because it is one of the things that comes up more. So the other thing was that people found the app easy to use and the instructions easy to understand. And the last slide I want to present is that we did ask people if they were going to record their speech again, and overwhelmingly people said yes, to both help them manage their depression and within the context of a research study. So this is really cool. We're able to collect and analyze some cool data, and overall, if we design the task well enough, people are happy to give us our speech. So I'd just like to end by thanking everybody who provided their speech, completed our surveys, everyone involved in Radar CNS and Redarbase, and to also acknowledge the work of Dr. Judith Dineley and Edward Campbell, whose inputs have gone into making this presentation. So thanks, everyone.
Hello, yeah, Mike Craven here, at Nottingham.
Hi, Mike.
Hi. Yeah, great, really great to get the summary of everything. I just had a lot of what you presented was means. I just whether you've got any sort of insights into sort of individuals and maybe within subjects about what sort of percentages of people are actually finding that they are seeing a difference in their speech, maybe compared to others that may be getting quite a strong. So maybe not seeing very much difference, or maybe a group of people who are within the cohort who are finding a very strong differences when they have a high depression score, or is it all really just population level at the moment? And I suppose a question relating to that then is there any work that either been done or that you've seen elsewhere where people are being asked whether they concur with what they're seeing in the data in terms of their own speech, and seeing when they're depressed or not, yeah.
Some really good questions there. So to go back to your first one, no, so far we've just done a more population-based analysis of the data, and there are quite a few things at the individual level we need to unpack in terms of patterns of both how people gave us their speech, so look at patterns of missingness, and then also patterns of speech changes over time within individuals to see, as you said, who changed, what changed, and then maybe use those clinical insights as well to sort of go, what might be some causes, what might be some similarities between people who did and didn't see a speech effect. And we know from other short-term longitudinal studies, there are definitely people who do and don't have speech effects. So it's worthwhile digging in further. And I think one of the first things we'll do, and one of the things that will get talked about over the next few days, is subtyping in the depression cohort, definitely towards people with different forms of depression, especially melancholic depression, as being one of the entry points into that analysis. In terms of feedback on if people agree or disagree with changes in their speech, it's a really cool research idea, and I'll definitely talk to you sometime in the next couple of days about having a look at that and potentially how we could do that, because it would be very interesting, and there's not a study that I'm aware of that does that. I think one thing we need to look at is how to robustly sort of extract the information on a phone and provide this information in a little more real-time scenario to allow people that bit of extra feedback, and it would probably help also get sort of adherence up in this style of studies.
Great, thanks, Nick, and yeah, great work, and look forward to hearing more in the next couple of days as well. Okay, bye.
Thanks, mate.
Any more questions? No questions there. Nick, there's a question on the chat, which is from Vera from Ligature, which says, thank you. I might have missed it, but is there a chance that you can predict relapses based on the speech data that you've collected so far?
I've had one of the issues we have with predicting relapse as a relapse event is that they're particularly rare, and we actually only have a small number of relapses across the whole data set, and a very small number of relapses where we have sort of speech before and after the relapse event within sort of suitable timeframes to make such a prediction worthwhile. What we can do is use machine learning analysis to predict we did some machine learning analysis to predict if someone was a low or high depression according to their PHQ-8 scale, and we were roughly able to get about 80% accuracy in doing that using some machine learning, some deep learning techniques, which, given the complexity of them, I didn't want to present today just for timing reasons. But in terms of like a very clinical definition of relapse, we haven't had a look into it. I'm not expecting a breakthrough finding just because of a lack of numbers more than anything else. We need to do more speech studies.
Yeah. Okay, thanks, Nick. That was really a fantastic talk. And we didn't do an intro for you at the start, I don't think, but just to, so doing it in reverse, Nick is a lecturer in AI for speech analysis for health at the Department of Biostatistics and Health Informatics at King's. Okay, lovely. Thanks, Nick.
Thanks, everyone. And yeah, feel free to reach out via email or Twitter if you do have further questions later on.
So next up, we have Xiaosheng Sun, also from King's, who joined us in 2018. He did his PhD at Philips Research and Eindhoven University of Technology. So his area of expertise lies in signal processing and machine learning in the context of mobile health. And he's been working on some of the depression data, some MS data, and some ADHD data. And he's going to talk about some of those analyses and some of those analyses in the context of COVID.
Yes, thank you. Is my screen? No. Can you see my screen? Also, I see we need to do some adjustment.
What do we need to do to get the presentation up?
Do I need to? Yeah. So, one, I speak. Do I need to do?
Yes. Yeah.
Okay. Okay. Yeah. Okay. Well, we are just waiting, so I'm just to say hi to you guys. Yeah, it's my first in-person meeting for the past 2 years, so I'm kind of a bit nervous right now. So kind of just relax and. Okay, so my name is Shaoxiong Sun, and I'll kind of talk about my research. So the first thing is about, since we have seen in several talks, our database is such a powerful toolbox. And then at the very beginning of COVID-19, I want to see whether we can use COVID our database for some other purposes. Like I want to see whether we can use our database to play a good part. So that's the very basic idea there. So I want to test the utility of our database as a toolbox to see the effect and response of non-pharmaceutical things like lockdown on the behavioral changes on the people from our radar CNS work. So basically, we had 1,062 people in our data site, and we want to just compare their behavioral. Oh, sorry, it's not one. So we just want to compare whether we see significant differences pre, during, and post lockdown. That's the basic idea. So for the methods, we extracted quite some features from phones and wearables. We extract the features in three cans, so which represent mobility, physiological measures, and phone use activity. And like I mentioned, we compare the behavioral differences between the baseline pre and during lockdown. And also, we investigated several parameters that may have an impact on their behaviors. So here's a list of our features. So basically, we have features to quantify their distance traveled from home, durations for home stay, and also maximum number of nearby devices which are Bluetooth enabled, and also daily step count, and also some other parameters from physiological measures such as bedtime, sleep duration, and heart rate, and also virtual social engagement such as unlock duration and social app use duration. And here's just a visualization for one of the countries we have been focusing on, which is Italy. So we can see, so perhaps you can see several lines here, but if we pay attention to the right dotted line, so which can be hard to see. Yeah, so that one. So we can see that. So that's the line marking the national lockdown. So basically, we see that after the national lockdown, we do see significant behavioral changes in most parameters we have been looking at. So that's just one example, and based on 200 people. And also here's a more systematic comparisons for different countries we looked at. So we have 5 countries here. We see that in this figure, we see that after during the lockdown, we do see that they have a very big change in their behavioral patterns, like they traveled much less and they work having much less physical activity. And also here are some other parameters. I won't go into details here. Here's just a bit summary here, summarize what we have found here. So basically, participants, we found that during national lockdown, people spent more time at home, traveled much less, and had fewer nearby Bluetooth devices, and were more active on their phone, talking to their friends on social apps. And we also found that people had much lower heart rate. slept more and went to bed later. And we also find that different responses in different countries. So perhaps it's kind of I cannot see it very clear, but I mean for country Denmark, so we do see that its response is much less compared to the other 4 countries. So perhaps it has to do with the social distancing measures or some other factors like how they are in compliance with the policies. So that's just one. So the other thing I want to do is also to see how our database can be used for people with MS. I think perhaps you don't know too much about it. So just to give you a bit background. So for the MS population, so there is one standard metrics called EDSS, so which is to evaluate the progression of the disease. But it comes with certain drawbacks, like it's being reliant on readers' subjective examination, and also for its course granularity. And recently, there has been a parameter called 6-minute walk test, which is a popular alternative, but it also comes with a need for hallway with sufficient length, and also for some severe patients, they find it very hard to finish it. And since we have the luxury to have a database, so we are trying to understand whether wearable devices can offer a way to continuously monitor MS patients in free living conditions and to kind of get a better biomarker. So the aim is to see the utility of wearable devices, especially the minute level step count data in free living conditions in terms of monitoring disease progression, and then we compare the parameters from the wearable devices to the 6-minute walk test. And the method is, we extracted features, like I just mentioned, we extracted the features from the minute level step count data in a 60-day window around the 6-minute walk test assessment. We also included other demographic factors such as the need of working out, and we built our regression models to estimate the 6-minute walk test, and also we compare the features and rank the features based on their importance and contributions. So here's a list of features. I won't go into details here, but it's all about I want to dive into the minute level step count data, and we tried to extract meaningful features from them. So, and also just to remind me that, so here we focused on the statistics of the minute level step count data, since we are given the 6 window, and also sometimes we may have some data loss. So using some statistics capturing the upper end of the data, so we are trying to mitigate the impact of data loss. And here are some results from our estimation model. So we can see that with our model, we can indeed have some plausible results from the regression models. And also we can, if you see the figure on the right, so we can differentiate between people with a severe MS and also and people with less severe MS. So here's just ranking of the features. So we can see that, well, it's not surprising that working out is the most powerful features. I mean, since it's very straightforward and it really can be very kind of distinguishable. And also we see that the features we extracted are also very helpful since also if we see the window length, so we can see that for the activity within small town windows, they are quite helpful, and also the upper end of the distribution are very helpful. And the last part is about monitoring of people with MDD, so which has been talked quite a bit. So here I'm focusing on three issues that have been less talked about in the feature. So first of all, I want to see how the missing data can have an impact on the feature quality. Since we have been talking about like how to extract the features within a kind of time window of given length, but we do not know like when we have this fixed length of the window, how much missing data can impact the feature quality. So the first thing I want to cope with is to see the impact of missing data on feature quality. And the second part is about the nature of correlations. I mean, so there has been some papers talking about correlations, but they do not really differentiate between cross-sectional and longitudinal correlation. And from my research, I found that so for some features, so they can be quite powerful in cross-sectional correlation, but but they did quite much worse in terms of longitudinal correlation. So I would definitely need to kind of tell them apart. And the last part of my research is about things we sometimes will assume that behavioral changes can be the same for all people, but which is not the real case. So I want to look at whether there are some underlying clusters within the kind of patients in terms of how they change their behaviors when they become depressed. And that's all.
Thank you so much. It's really interesting work and presentation. Yeah. So I just wonder about your results in relation to the COVID. Yeah. In relation to the COVID. So you found that. Here. So you found, for example, that heart rate is lower, right?
Yeah.
And at the same time, people started to sleep more, and I believe activities also got reduced, right?
Mm-hmm.
I'm just simply thinking. So heart rate during the night is going down, right?
Yeah.
If you sleep longer, if you take average through the day, it also will go down, right?
Yeah.
Heart rate is going up when you are active, right?
Yeah.
If right now you're less active, in this case, okay, so heart rate is also lower, yeah?
Yeah.
So right now I just want to understand, so when you claim that you have a lower heart rate, it's just because people start to sleep longer and become less active, or it's not relation to this? So when you look into the lower heart rate, have you controlled for the sleep duration for activity or not?
Yeah. So thank you for your question, Korea. So that's a very nice question. So I think so from my perspective, I think there can be kind of several reasons for why we see the lower heart rate. So as you mentioned that that can be that they are in bed longer, or they kind of will be less physically active. But right now, I mean, from our data, we haven't really differentiate between them and see which is the driving force. So kind of we don't really have answers for that, but I definitely see this is a very good question, and yeah, I guess it's kind of just a mixture of both, I guess.
Okay, thanks. I just simply want to understand why the heart rate goes down.
Yeah,
oh, thanks.
That's a good question. Thank you.
It touches upon the point of like determining causality. I think was mentioned earlier. It's tricky, and this is all real world data. It's all
Maybe you could just repeat it. Is it the 24-hour heart rate that we're talking about?
So yes.
Average through the 24 hours. At least what I understood.
Because FIT
yes.
looks at the resting heart rate for night time, doesn't it? But this is the radar data set with the 24 hours, is it?
24 hour, but it was just looking at the resting heart rate here.
Well, so here what we did is like we just since the time was quite short back then, so we just take the daily heart rate. So we do not really focus on the resting heart rate. So that's kind of so that's the daily heart rate. So that can be quite some factors here.
Okay, just
that's true.
Might help to clarify, because when Fitbit gives it you, it's only for night time. So that's all. Sorry. Thanks.
Thank you. Yeah, thank you for the question. Yeah.
So just clarify that, Sharon. So you took the daily average of the sleep of the heart rate, yeah?
Yes, that's true. Yeah, that's true.
Thank you.
Yeah, thank you.
Okay. Any more questions? Any questions online? No? Okay. Thank you, Sharon. And so next up we have Yatharth Ranjan again. And so this time Yatharth's going to be talking a little bit about the integration of Internet of Things sensors into radar base. You might also have seen a poster relating to this talk out in the foyer as well. And just whilst they're setting up, just a note that in the break we're going to try and have gather everybody together for a photograph. And should we gather here for that?
Hello again. So yeah, I'm guessing you might have seen the demo out in the lunch area where we have the TV with the real-time IoT data coming in. So that's the radar IoT framework that we have recently been working on. This is still in like a proof of concept stage at the moment, but yeah, it does have a lot of potential to be used in research studies. So today we were talking about like what is Internet of Things first of all, and then why are we integrating Internet of Things into radar base? Like what are the benefits of it? Then we'll discuss some design requirements and architecture considerations that we want to take into while developing such frameworks. Then the use cases, or more accurately, the deployment use cases for radar IoT. And then we did like an in-house proof of concept of the platform, of the framework, because we just wanted to see if it is working fine. The sensors we have integrated have been integrated well enough for them to be used in real-world use cases. And then, because this is still in development, so there are some limitations, and then the future work will mostly involve mitigating those limitations. So what is IoT? So it's just a very generic term describing a network of physical objects or things that can have that are very, very varying, ranging from like embedded sensors, software, any other technology that creates an interconnection between different things with the purpose of exchanging data. and system, like it can be over internet or it can also be in a private network. A terminology used in IoT is an IoT gateway. So simply put, an IoT gateway is a physical device or a virtual platform that connects sensors, IoT modules, and any other smart devices to the cloud. So think of it as like a wireless portal that gives IoT devices access to the internet. It's very similar to like your Wi-Fi router you have at home, but it has much more complexities involved in it. So yeah, it does support like different types of protocols that are common in machine-to-machine communications. And it also supports cases for edge computing, like if you do want to do some analyses or real-time analyses on the edge, at the edge where the device is placed. It can also collect like massive amounts of data from interconnected devices and sensors in any given ecosystem. So you can have, because there's a massive catalog of sensors, IoT sensors that are out there, because they follow the same protocols of input-output communications. So you can actually integrate a lot of different sensors which are currently not possible with wearable devices, which have only a limited number of vendors and sensors provided. So why? What's the motivation behind it? So in a recent study, it was like the IoT in healthcare or the Internet of Medical Things sector of the market will reach like $34 billion by 2025, expanding at a rate of 19.9% annually. In 2018, this was only $147 billion. But still, around 50% of the doctors believe that IoT devices are not reliable because at present, the IoT data is not often processed or it is not provided in a form that is actionable or provides a valuable form of intelligence or knowledge. But if we combine this IoT part with a mHealth platform that can analyze the data in real time from multiple sources like wearables, IoT sensors, your questionnaires, and provide like a high-level integrated view of the information, this could be provide very valuable to the doctors and the patients even. So there is a gap in the market and there's a shortage of like these open source mHealth platforms that allow interconnected IoT devices and offer a common interface for collecting, aggregating, analyzing real-time data from multiple sources like wearables, IoT sensors, mobile devices, medical devices, and this could be used for both clinical and research domains. So this provides us with an opportunity to create an edge gateway IoT device that can interconnect with a well-established mHealth platform like Radarbase and can have multiple use cases like integrating IoT sensors, can even perform some rudimentary analysis at edge, does integrate with the mHealth platform as well. So in terms of benefits to Radarbase, so currently Radarbase is more focused on personal sensing. So like these devices are mostly battery powered like mobile devices or wearables and are carried on the user. But these are limited by the vendor availability of devices, like they provide SDKs and REST APIs for integrations. But if you're using static IoT sensors like you saw in the lunch area, there's like a very, very wide variety of sensors available, and that could open up a lot of new use cases in health and even other domains. So these IoT sensors can be installed in static settings. That means that they are constantly connected to a power source. That means that they can overcome the limitations of mobile devices such as battery and resources. So this enabled power also allows us to perform some power-intensive tasks like artificial intelligence or machine learning at edge, and like just extract features at edge and then upload them to the cloud platform, so making it privacy preserving. Also, it does provide us a lot of more configurable options, like you can configure the sampling frequency, sampling rate of each of the sensors separately. You can turn on and off the sensor at a hardware level remotely, which is not possible in wearable devices. In terms of Radarbase, it provides like a holistic view of users' health and environment. So the ones in the red, these are the devices or the data sources that are already integrated in radar base. But radar IoT also provides information like environmental sensors, like indoor air quality, temperature, humidity, gas levels, motion sensors, many more. Provides us the ability to get background audio, video of the environment, and with an optional on-device feature extraction or detection of an event like cough detection, for example, using audio data. So we don't have to actually capture any privacy-related patient data. We can just extract the features on the device and then get the data in radar base. So as I said, there's a huge catalog of sensors. This is just some examples that I just picked up from these sensors that we support. So most of these sensors are supported. They just need a little bit of additional configuration to be enabled. And we have some on display in the lunch area as well, some of these. The design requirements are very similar to what in my previous talk. So it's like it should be extensible, allow new use cases, new sensors, new devices to be added in the future. It should be modular, allowing services and components to communicate through a common API or machine-to-machine protocols. Should be built on a publish-subscribe pattern. So this is the pattern that we already use in the radar-based backend. So that's the Kafka that we're using. That's like a message broker. So that's like publish-subscribe. So in this pattern, there's a message broker or a queue, and many publishers can publish to that queue, and many consumers can read from that queue. So it's like very interoperable method of or a design pattern for interoperability and scalability at edge. So this allows the data to be consumed, processed, and uploaded in different ways that are flexible enough to accommodate any new use cases. And then there's a design requirement on running it on low power and resource edge devices like Raspberry Pi Zero. And it should be reliable to allow continuous monitoring and reliability of the data collection. And because we already have a lot of code relating to radar-based platform like clients to upload the data, so it should be able to use existing libraries for that. And yeah, it should support data analysis and AI or machine learning at edge. So yeah, this is just benefits of using publish-subscribe. So as you can see on the model, there's like publishers, and then the publishers publish some data to a channel or a topic, and then it's actually not visible, but there are a lot of subscribers that subscribe the data from that topic. So if you use an external and tested publish-subscribe system, it makes the system reliable and creating our own internal message bus. Allows a framework to directly dump data to the cloud, allows various different types of consumers to consume data. So that could be like just a consumer that is consuming the data and then uploading it to the radar-based platform, or it could be just an external service or application like running an AI or ML workload. So it also allows opposite of this, so there can be multiple publishers, so multiple radar IoT devices that are publishing the same pub-sub broker. And this allows, again, for like event-driven programming or real-time analysis at edge, like we saw in the cloud in my previous talk. And this also allows the platform to be language and platform agnostic, because the publish-subscribe broker is very, like it's an industry standard, so it has clients in all the languages and platforms. Next, we plan to use an API standard for IoT, that's OGC Sensor API standard. So we have not implemented the whole standard. It's just some things that we have taken from the standard. So for example, the topic or the channel names in the publish-subscribe broker will kind of be self-describing. So like sensor, then the sensor name could be, for example, air quality. So sensor / air quality / data stream will provide the data stream, / error will provide the error messages, / control will allow us to control the device, and / config will just allow us to configure the device. And this can also make it more self-describing if we have like a common sensors endpoint, and that sensors endpoint like exposes what sensors currently are integrated or currently are enabled in the system. So this is like we then created based on these all standards and design descriptions, we created Radar IoT framework, which is an extensible and flexible IoT gateway framework for plugging in variety of different sensors and using those as inputs for processing of different data in different ways. So it obviously supports uploading the IoT data to a radar-based platform, but there are multiple different ways that you can consume that data. So like, for example, you can directly upload that data to an InfluxDB and then view it real-time in Grafana. You can easily add more data processing variants and more sensors, and as I said, it is language and platform agnostic. This is a high-level architecture of radar-based. We have multiple sensors, and there's a sensor data I/O layer, and then there's a converter which converts the sensor data to a format that's acceptable by radar-based because we use schemas for data standardization. And then the publisher publishes that data to the publish-subscribe platform. So we are currently using Redis for that, but later we plan to support MQTT protocol as well. And then on the other side, you can have multiple subscribers, and one of the subscribers is data consumer, and that data consumer uploads that to the radar-based platform or a real-time dashboard. And you can see all of this is running inside like an edge IoT device, like a Raspberry Pi. So if you don't know what Raspberry Pi is, in my next slide, that's the big device on the top there. Now, a detailed architecture. So you have like different sensors, and they have different hardware interfaces like I2C, serial, GPIO, analog. And then we have third-party middleware. There's the libraries that make it easy for us to integrate these sensors. So there's GrovePy library, there's SMBus, there's RPI, GPIO library. And then we have Radar IoT Python sensor implementations that kind of use these libraries to get the sensor data and convert that sensor data into a data standardized format and then publish it to the Redis publisher. And then on the other side, we have Radar IoT data uploaders that are uploading the data constantly to the cloud. And we also have data analysis and processing on the device. And then we can have other consumers and subscribers like Node-RED workflows, which I'll go into detail in a couple of slides. So this is the real-time dashboard. It's also being shown on the TV in the lunch area live. So yeah, it just shows different. So this was a while back from our lab or office where we work when there was no lockdown or stuff. But yeah, so the green bars you see are weekdays and the blue bars are weekends. Oh no, sorry, opposite. So the green bars are weekends and the blue bars are weekdays. So weekends no one was in the office, and weekdays people are coming into the office, and you can clearly see the difference. Like the bottom one is the motion sensors. You can see the motion sensors are triggering, and then also the air quality. The top one is air quality. You can see the air quality is much worse, like it's higher values during the weekdays. So the deployment use cases is where, because of the modular architecture of Radar IoT, there are various different ways you can deploy the platform. So you can have like the whole Radar IoT framework running on 2 different devices in 2 different rooms, and both are connected to the internet, and they are uploading to the radar-based platform in the cloud where they have different sensors connected to them. But another way is like a master-slave configuration. So one master gateway is running the whole Radar IoT framework, and that can have sensors connected to it. But then on the other rooms that don't have internet access, you can just have wirelessly slaves that connect to the master and then just send all the information to the master, and then master uploads it to the cloud. So this is really useful for like cases where internet access is limited, like in hospitals. And similar with local networks. So if you don't have internet access at all, because all of these components that we have developed here are open source, you can just put them on a local computer. So like radar-based platform can run on a local computer. And the visualization, like Grafana, is also open source. So that can run on a platform, on a local network. And then everything is on a local network. So you don't even need cloud to run anything in the cloud. The next interesting bit is the Node-RED workflow. So Node-RED is like a programming tool for wiring like together different sort of things like hardware devices, APIs, or even online services in like new and interesting ways. So this is like a browser-based editor that like provides a visual interface for programming. So our platform works fine with this because it has like a Redis node, so it can read data from Redis. And after it reads, after you get that data in here, you can do anything with it. It has a lot of different nodes or various ways you can do what you can do with it. So for example, this is just an example I created for emailing admins in case there's no data for 2 hours in one of the data streams in Redis. So like it just takes data from Redis, parses the JSON response, and then there's a function, and then the trigger is like 2 hours, and then it sends an email. So it provides like an infinite combinations of things that you can do without even programming anything for the radar IoT. And on the bottom side, it's like it even has modules for like machine learning and outlier detection. Just maybe 4 or 5 minutes, if that's okay. Yeah, so this is just using radar IoT with other platforms. So you can use like third-party platforms because they support the same machine-to-machine protocols like MQTT. So for example, Google Cloud IoT, you can use that as well with radar IoT, so it's not limited to radar base. So management and administration, so because we want this platform to be scalable, so it could be the case that we want this to be deployed to a scale of hundreds of thousands of IoT devices at edge or in the field. So all of these components that I mentioned are provided as Docker images, and they're also provided as a stack of Docker Compose services, so it's easy to deploy and manage. Now for orchestration, there's a software called Nebula. It's very similar to Kubernetes, but it's specifically targeted towards IoT. So that can be used for orchestration, and like for example, you would update the software of hundreds of devices on the edge. And there's I don't want to go into detail of these, but these are other like monitoring tools or management and administration tools you can use alongside this. So just to get the ball rolling and have some sort of real-world case study of this, we just did a simple proof of concept in-house, like in our lab and in our homes, to evaluate and demonstrate the framework works in a real-world setting, and that the sensors work as expected, and just to collect some real-world data. So we just deployed it in 2 settings, in a lab and at home, and then we used 4 types of sensors: air quality, motion, temperature, humidity, and light. And then for some days, we just kept like a diary of things, like if you opened a window in the room and stuff like that. So this is just a quick proof of concept results. On the right side at the top, you can see the completion rates. So like the completion rates are very satisfactory for 3. So these are for 3 months running continuously. And then on this, we found the correlation between open window event with the sensor air quality data was around -0.6. That's good. This is expected because opening the window will improve the air quality in the room, usually. On the bottom right side, you can see there's like a periodicity of data in that graph. That's the light sensor data, and that just shows like in the morning the sun rises and slowly the light sensor values go down during the night. And then there's a little peak just before it goes down. That's when I turn on the artificial light in my room. And then after that, it just goes down when I sleep. And then again, it peaks up in the morning. So yeah, all things as expected. So this was just a proof of concept thing for the IoT. I think I'm out of time, but yeah, it's just limitations and future work.
Brilliant. Thanks, Jafar. Thank you. We might have to move straight on if the next talk is there, but people can catch you in the break.
You can find you maybe by the demo.
So, yeah, thank you. So,
Hello?
Yeah, great. We can hear you.
Okay.
So, Eleni Kapousidou
Yes.
is a data scientist at the Center for Human Drug Research, CHDR, in the Netherlands. And she's been there since 2021. The CHDR specializes in innovative early clinical drug research, CRO organization. So Ellie's going to talk, I think, a little bit about her experiences at CHDR using mobile health, using radar base in a kind of this CHDR setting.
Yes, of course. Can you see my screen?
Yeah.
Okay, and you hear me well?
Yeah.
Okay, great. So, hello, ladies and gentlemen. My name is Eleni Kaposidou, and I'm delighted to be there today with you to present the case study and so how we use rudder base at CHDR. I'm sorry, it is stuck. So I am a data scientist at the Trial at Home department of CHDR. What is Trial at Home for CHDR? It is the strategy that it has in order to implement decentralized clinical trials. So trials that happen at home. Lately, the last 2 years with the COVID situation and the pandemic, we understand that it has been very visible to all that implementing traditional clinical trials it was very difficult since patients and participants have to be present at the clinic. So we see that the concept of decentralized clinical trials, it has become very, very popular. The trial at home as a concept, like the traditional clinical trials, is based in some pillars, some main pillars, like the trial design and the operational execution components, which are the same. It's the phases where you have to design the trial, set up the protocol, find the participants, execute and manage the trial and set everything and see the progress and track everything. And then there is the data analytics component, in which is the field that I am in. With Trial at Home, we have the advantage of having a lot of data in the data analytics part. In the traditional clinical trials, the participants would usually come the first day, would measure some features, and then they would go away maybe for a week or 2 or a month. And they would come back again at the end to measure again the same features. But with Trial at Home, we are able to have continuous data from the participants throughout all the study, and we have thus a lot of data that we analyze and try to find some conclusions from them. And finally, another very important part and component of the Trial at Home is the technical backend, which in our case, it's rudder based. So Trial at Home at CHDR, it started at 2017 when the backend development started. And by 2018, we had our CHDR More server and our on-site server, which we still use to store all of our data. But the plan is by the next few months and by the end of 2022 to use the cloud architecture and all the advantages that this offers. So in practice, as I mentioned before, the last 2 years made the Trial at Home concept a lot more popular. So Trial at Home is also very visible and present in CHDR studies. It's been present in more than 15 studies, and this means that we have a lot of continuous data from our participants, more than 50 days per participant on average. What we actually use at Trial at Home and how RudderBase helps us is we use data from smartphones and wearables. So RudderBase is very helpful because we can use the passive monitoring app that there is in RudderBase, which we developed as a CHDR More app to give to our sponsors and to our participants. But it does the same. It collects smartphone sensors data from the participants' smartphones. We also use the questionnaires, the digital questionnaires that the application that there is in RudderBase. So we use that application as well from RudderBase, since digital questionnaires are really important in clinical trials, questionnaires in general, actually. We, as Trial at Home, are mainly using the WeThings wearables, so to calculate steps and heart rate, blood pressure, etc. So we were able to integrate the WeThings platform into our backend system in order to have the data from the WeThings wearables stored in the same place as the other data that we collect from our participants. In some cases, in some studies, we had to ask the participants to do some pulmonary function tests at home. So there is a spirometer that they can take at home, and they can implement those tests. And we were able also to integrate that system into the CHD Armor app and get our data in our backend, in our platform, in Rudder-based platform. And in the end, we also integrated some environmental data that might be useful for our further analysis. So all the data that we collect, we have them in a secure and safe place, and we can use them from there. So now I can explain a case study. So a study that we had at CHDR that used Rudder-based. The study was about, it was trying to estimate, it was about creating a tool that would estimate the severity of the FSHD disorder. This disorder is a muscle progressive degeneration of it's a degeneration of muscles that a lot of patients have at the beginning. They have some weakness and some atrophy in their muscles. We can start being very light, but in the end it can be very severe. So our goal was to create a tool that by collecting wearable and smartphone data remotely, we could be able to estimate the severity of this disorder. We had for this study 38 FSHD patients and 20 healthy controls, and it lasted 6 weeks long. So we gave the participants smartphones and wearables, and we collected all the data, and we developed some regression models using the most important features from all the data that we collected in order to calculate the scores. So the results, they were very good from our regression models. But they could not replace the actual assessment that is done in the clinic when they are calculating the FSHD score or the time up and go score. For example, the time up is the score that the participant is seated in a chair. He's been asked to stand up, walk for a distance, and come back again. So these scores we were able to calculate them accurately from our model, but it's not. It's a complementary tool. We don't suggest it cannot replace the actual assessment. What we haven't looked for in our study is if this tool would be able to detect some changes in that severity score of FSHD due to the progression of the disease by itself or due to some drug intervention. So that would be a follow-up study that we could do using the remotely monitored data and Rudder-based. So to conclude and to say about the Rudder-based, for which we are here, and what was our experience with it. I have to say that we found out that it is a very reliable platform, and we didn't have any issues regarding the collection of the data, or if we had something, it wasn't something really difficult to solve. It allowed us to integrate, like I mentioned, the spirometer and the WeThings platform in our system and collect the data from there. It is scalable and is modular, which is very important for us, so we can use only the modules that we want in our studies. But every coin has two sides, so there are no pros without some cons. We just, from the use that we had experience with Rudder-based, we just find it a bit, the setting up and the maintenance, it's a bit difficult, so we need someone who is expert and in order to be able to set it up. And also we understand that it is it has to fit a lot of many needs, so it has to have some core components to fit those many needs. But in our case, the people who use it are people who, in the end, I mean, the management system is, there are people who just follow some standard operational procedures. So maybe some extra features in their interface would make them, it would make it more difficult for them. And since they're core components, some of those, it's a bit more hard to take them off. But for sure, it's not a big issue. And finally, it would just be nice to have some more extras in the interface to make it a bit more easier for the users. But still, these are not big issues. So it's not that they're deal breakers and that we find the use very hard. It's an easy platform and really user friendly. So thank you.
That was excellent, Eleni. Thank you. It's really nice to see the platform being taken and used and adapted for your own purposes there. Are there any questions from anybody? Simon, and then Jafar.
Yes, thank you. Your integrations with the Witherings platform is obviously very useful. Have you got any plans to open source that element?
I'm not quite sure how is it from the Withings side to open source that, but maybe it could be done. I'm not quite sure exactly regarding that matter, but it could be. I think if it's okay, yes, it could be done.
And okay, that was the same question I think from Yafaf. Any other questions? So do you think you were kind of benchmarking against that clinical gold standard measure? Do you think that is the ideal measure to be benchmarking against?
You mean the FSHD scores and the time up and go?
Yeah.
These are the actual scores that are being used in the clinic. So yes, I think that these are the gold standard. If I correctly understood, yeah, these are the standards and the scores that we would use for that specific disorder.
Well, I was just wondering if they, if you think they are the optimal scores in an ideal world, are they the, is that the best score?
Okay. I couldn't say that it's the best score. Yeah, no, I don't think there are always improvements, so I don't think that this would be the ideal score.
It's difficult, isn't it? Sort of trying to kind of correlate or associate these measures we get from the devices and wearables with, measures which may not be the optimal measure.
Yeah, it is hard, so that's why it cannot. We cannot be sure. That's why it needs to be assessed in the clinic, and it needs to. They can use the tool as complementary exactly, and because these things are very subjective, I would say. So it's very difficult to have one exactly ultimate score and be sure that this is it.
Okay. Thanks, Eleni.
Thank you.
So, do you know if the combination of the score and the wearable data was together improved beyond the sort of a standard score, or?
I'm sorry. I didn't get the.
Sorry, if I was not following. The score is that a combination of the wearable data and the gold standard?
Yeah. The score is a combination of the data that we collected, and it's compared to the scores.
Okay, thanks.
Okay. Thank you. So on to the next part. I believe we're running slightly late, 15 minutes late nearly. So we're going to move on to Amos talking about doing a piece on the radar-based community, onboarding new contributors and organization of the community.
Okay, so I've got a quick talk, and I know we're running a little bit behind schedule, so I'll try to make this make up a little bit of the time that we've lost. So this is just a quick overview of the radar-based community. Since the start of the project and the decision to make radar-based an open source application, we've been trying to make sure that we're bringing alongside the kind of community, and the aim is to kind of try and make this a little bit more self-sustaining in the sense that as other projects come on board and use the platform, any additional developments or extensions that they're creating somehow flow back to the project. That's not an enforced policy, but it's generally what we're trying to aim for. So these are just hits on the unique hits on the website over the course of the CNS project. So there's interest from various sort of parts of the world. The idea was to again use the community as a means to test where we want to extend, as a sort of to collect back kind of ideas from groups of people who are interested in this type of work, to keep things sort of generally configurable, and radar-based was definitely made with the intention of not being specific to one person's use case. That can be a strength, but it's also it also in some senses can be quite a burden to try and focus on being generic constantly. So as well, we provide some resources for documenting the platform. We obviously have some activities on social media. There's a sort of consensus on what code of conduct should be, and how kind of this sort of body of volunteers can help. What sort of the level of kind of support that they can provide as part of this sort of mutual help community. And then there is forums for discussion. There's obviously the sort of centerpiece, which is the GitHub repositories. So there's an organization for the radar-based code. And then there's websites and wikis, and we also run an online meeting once every 2 weeks. And as well, we will provide some degree of sort of consultancy or input into new research projects and proposals. So how to participate in radar-based? So anyone's welcome to join. Start a discussion on the Slack channel. We're very happy to sort of hear about new ideas. People often come with a research project in mind, or a disease area they're thinking about working in. Maybe they want to integrate a new sensor or wearable device. So as well, people may well want sort of some help in doing all of this. There is a degree to, I guess, within the kind of community to which that can be supported. But as we say as well, there are sort of service providers of radar-based who will take your kind of use case and help you to sort of build out the solution to that. Software development. We're always happy to sort of help new contributors start with radar-based. This might be sort of as much as just testing applications or reviewing code, improving documentation, but also writing a new components and adding those to what we have already. As well, vendors who may be interested in having kind of their hardware, but maybe lacking a back-end application for sending that data to, have also been people who've been interested in radar-based and participating in it. So all of the slides are available online, so I'm not going to kind of keep this up too long, but these are generally, this is just sort of an information page where you can go and link out to various resources there. I think most of this is replicated on the radar-based website. Radar-based website, just sort of hub for most of the kind of linkage. We are working eventually on a kind of redesigning this once we've got a little bit of bandwidth to do that, but that is sort of a work in progress. The Slack channel, I should say, if you want to sign up, there is not a direct link on the website. So if you can fill out the form, so we just have a little bit of information about you, and that just helps us introduce you to the community. And then, yes, you receive a link to join the Radar-based developer Slack channel. Okay. We also have a Confluence wiki. So we don't want to keep information just guides, documentation around the platform. Usually, this is stuff we don't want to put into the GitHub repository, so more sort of general guides and some information there. But usually that's a good sort of port of call if you're interested in learning a little bit more about the platform. So there is a Radar-based GitHub organization. There is a rather large number of repositories on this, I think, as Joris mentioned some in his slides. We've tried to sort of pin some of the key ones onto the top of the repository. So if you're interested in Radar-based, and I think a very good sort of starting point is having a look at the Kubernetes repository. There's obviously the management portal. There is the two main apps in the project. And then there is sort of the Helm chart. So Helm charts sort of wrap all of the various components that get installed when you deploy Radar as Kubernetes. Kubernetes is, I think, now sort of the sort of standard we're recommending as the means to deploy Radar-based. So we're deprecating the other older systems. Okay, so I mentioned we have the forum for Slack. What we actually prefer is that people who come with a specific kind of goal in mind with regards to the software actually go to the GitHub repositories to start discussions. And the reason for that is Slack is a little bit more difficult to sort of search and maintain. And if you come across a problem, there's a very good chance that someone's coming sort of, a few weeks later who's also interested in the same solution, or maybe, it's just much easier and much better to organize this if we maintain the discussions on GitHub. It's much easier to organize the sort of and reuse that information. So where someone contributes some effort to solving a bug or making some suggestions about how to configure something, then yeah, it's much easier here. And then we're also curating a starting point for people who want to actually get involved in building the software for Radar-based. So as I said, these slides the links are available online. This is just links to the wiki page that will give you a list of searches on GitHub. So if you click on the links on the Good First Issue for New Developers wiki page, each of those will link out to a GitHub search and will basically pull up some flagged issues that are good sort of starting points for new people who are interested in getting involved. We also recently, this just came out yesterday, so we were accepted onto the Google Summer of Code. So if you're again interested in that kind of thing, you can get involved with the Radar-based offering on Google Summer of Code. So yeah, there's details about that also on a GitHub repository that just sort of lists the various opportunities to get involved in some small projects that will greatly help the project, the Radar-based code. Okay, I think we'll have to move on. How will we the time? Okay. Any questions?
Okay, so next presenter is Julia. She's the team lead at the Hive, working with Radar-based, and she will walk us through the planned roadmap for the platform.
Yeah, thanks everybody. Is it on? Can you hear me? I think it's on. Okay, so thanks everybody for bearing with me. I know everybody's looking forward to the coffee break, but would be nice to have a good conversation here with you also, because I think this session is one of the sessions where we really would, benefit from also your input and a little bit the questions from, okay, what needs to be added in the future and what's currently missing. Because just to go back to the slides that we saw this morning, this is really what happened in the past where we started from Radar CNS. A lot of the milestones that we have reached, and I think also with the meeting today, the first annual Radar-based Symposium, hopefully the first of many. So we're really planning to have this as a yearly event so that we can come together, share our ideas and also the results that we're achieving when using Radar-based. And so the question is, where do we go from here? What's important for us? What do we want to improve? And I think so if you look at sustainability, there's a couple of key points that you have to have covered in order to have a strong community that works together in an efficient way. First point here is the platform and the components. I think we heard a lot of ideas already, how we're moving on from the components that we have now. But I think I'm going to walk you through them, and then we can also discuss if you have other ideas. And then next is, of course, community and user base. So that's really what Amos already explained to you, how you can contribute, how you can join the community. And then at the end of the talk, organizing the roadmap. So how do we decide what's important and how to move on from here? Platform and components. So I hope you remember this picture from how the platform looks. And there's a couple of things where we think, okay, here we can improve things. First of all, the onboarding and the registration. So what you saw is we have a management portal. We can recruit participants for studies. We can put them into projects, and that's all fine. But there's ways to improve on this. Then we have the PRMT, so the passive monitoring app that just collects the sensor and the phone data and the variables data. Then the ARMT, there's also some things that we want to improve, not so much on the app, but also how you set up the protocols and the surveys. And then last but not least, as also Pauline showed already, there's a lot of continuous developments also on the dashboards that we have now. Okay, and so when we start with the onboarding and the registration, there are two things that I want to cover. First one is the management portal 2.0. So what's the new functionalities that has been added? And then also something that we think about for quite a long time and that always comes up because we think it's nice for people that run studies, but also nice to just, increase the uptake of the platform, which is self-enrollment. And when we come to the next point, the ARMT, active data collection, what I just said, we want to make it easier for people to create their surveys and their protocols, because at the moment, you have to have some technical understanding and it's not super intuitive, and that would be a nice feature to change that. Next on the list is the PRMT. What we heard already, there's a lot of stuff going on with new devices. The talks from Yadad that we saw about the Internet of Things applications. So there's a lot of new things going on. And for the dashboards, I'm going to go more into the generalizability that we also heard already from Pauline. But starting with onboarding and registration, so what we have done for the management portal 2.0 is that we extended the functionality. So when we started Radar CNS, we wanted to have something that works, so you can recruit participants, you can put them in a study, but there's things that can be easier and more intuitive. And one of those things was that we wanted to implement organizations. So first we just had projects, but now we have organizations so that different organizations can run a couple of projects next to each other or in parallel. So that gives you a much better way of organizing your studies and your projects. Next thing that we implemented is the concept of groups and the assigning of groups to participants. So that will allow you to, for example, have different protocols for different groups. You can do A/B testing, so you can just compare much better than you could before. And then we also advanced the filtering capacities. I think something what we want to do next seems to be trivial, but is also something that's important. That's archiving of projects, because now if an organization has a management portal, you just add up all the studies and there's no way to, close studies and archive this. So this is something that is really necessary to help the the portal. And I think this is also one of the projects that we've provided for the Google Summer of Code, what Amos just showed. So there's hopefully going to be people that find it interesting and that also want to contribute here. And then the next one, I think something, what I said is really interesting to a lot of people, because how we set up database is something that that a researcher can set up a study. So you would register your participants. But what we want to do also, to increase the outreach and also to give more power to the patients, to make it more patient and participant centric, would really be something like a self-registration. So we've set up a couple of projects where we found some ways to have people participate remotely via an email or something like this. But I think it would be really nice to have like a web-based UI or something like this where people can register and then have a catalog of studies that would be interesting. Then they check whether they're eligible, and so then they can also fill in the consent and sign up for the study. That would be a really nice way to have more real-world settings and also have something that's more citizen science, right? So that you don't have to be a participant or a patient in a study, but that everybody can just contribute. And I think the Internet of Things that Yadav showed, I think that would be also really nice in this type of setting. And of course, the number of participants in your study would be much higher. So, and that's always a good thing, as we all know. Okay, then coming to the active data collection, I think we saw some really nice talks about the AMT, how is that set up, how you can use it, and it's also going to be used for the poster and the lightning talk prizes. So hopefully that all works fine. And so I think the app looks nice, and we can also change the UI depending on what your study is about, the type of audience you want to talk to. But we think there's a way to improve the process, for example, by making it much easier for the study lead or the researcher to set up the protocols and questionnaires. Because what we have now is like GitHub repos with a lot of code where people have to change, the questionnaires, and that's error prone to error, and it's also really difficult. And not all, clinicians or people that work on studies really know how to do that, and it's sometimes a hurdle for people to really use this app that actually could help them really much. So we think if there would be like a nice UI where you can just drag and drop your protocols together and find a way how to set up the questionnaires, that could be a big step to make it easier. And then also something we discussed a couple of times today is the integration of the Apple Health Kit data, so that we can also at least leverage some of the iOS data, because as we heard before, it's not that easy, but that could be a way to integrate it here. And also, I think one of the main issues or the bottlenecks of these remote studies that we all know is, of course, the compliance, and that we see after a while people are just dropping off if you cannot really make them comply and have a way to really keep them on board. And I think this is really something that we also want to address and find a way how to make it more sticky and make the people really provide their data, but also get something out of this, because I think this is probably what people need. So, of course, we're also thinking about gamification, having some sort of badges, but I think there's also something like a feedback mechanism or something, so that really helps people to manage their disease, for example, and I think that could be a good way forward here. But as I said, all those points, some of them we're working on, some of them are really just, ideas, and it would be really helpful at the end of this talk to really get your input also on what you think would be helpful. And then when we come to the passive data collection, that's some of the devices that are already integrated. As you saw on Nivetika's slides, there are already a couple of more at the moment, from RadID, for example. And what we're working on here is, of course, what you just saw, the Garmin wearables have been integrated, the IoT implementation, and then what I mentioned here is, of course, what has been discussed, iOS PRMT, that it's often requested but not likely to happen because of everything that Joris has explained, for example. Also, that if you want to do the data collection, that I think the app has to be on the foreground all the time, and I think that's something that's just not feasible for the studies. Okay, and then when we come to the visualization, this is one of the dashboards that also Pauline showed, which is currently mainly showing compliance. So is data really coming in from participants, or when do you as a researcher have to step in and make sure that the people are called, or that, that you find out is there a technical issue or something like this, so that you really make sure that you get as much data as possible. I think what we're planning to do here is two things. Also what Pauline explained, that you want to have a more generalized approach, because now you choose a dashboard specific for a certain study, but it would be nice to have a just more generic approach where you can just also choose which parts of the dashboards you would like to have. And then the second point would be the participant dashboards. I think also something that has been mentioned before, that compliance is nice for the researchers. We know which data comes in, that's helpful, but that doesn't help the clinician much, because you cannot make any decisions based on the data, or you cannot really discuss the data with your patients. So we would like to have some sort of clinician dashboard, but also a patient dashboard, so that the patient really gets something back when they provide the data, so they can follow their disease, for example, or compare themselves with other people. And this is, of course, also here to help increase the stickiness and make sure that people stay on board for as long as possible. Okay, and then community and user base, I think that's probably something that I can keep really short, because Amos covered most of it. And I was looking online a little bit, so from what can you do to really grow a community? And so the 5 points that you see here. Oh God, no. I think you have to do that.
Should be 6 hours each.
Okay.
You create 2. And stop at 3 hours again. So.
Is this? You can just say. People online are seeing you, so.
Oh, that's awkward. Okay, good. Okay. Yeah. No, that's fine. So then I will just continue without the slides. I think I will manage. So the next point that I wanted to make is the community and the user base. So of course, what we're trying to do is grow the community of people that contribute to the platform and that use it. And there's a couple of ways to do that. And I think we're quite well on the way with covering the points, because when I just read them, you will recognize that there's probably a couple of things that we're doing already. First one is make it easy for everyone to use your project. I think, we've put all the documentation out there. We tell people a lot about it. Everything is open source and available on GitHub, so people can just contribute. Next point is clearly explain how to contribute. I think this is something that Amos has started during this conversation here, but it's also all online, so you can find ways to just get started, find out, is there something that I'm particularly interested in? What can I do with my skills? Where can I contribute? What makes sense? Build personal relationships. I think this meeting here today is a really good, first step of this. Of course, we have built relationships already in the projects where we have worked together, but I think it's also nice to, bring together the people that are not in the same projects, because what we see, we're, a partner in a lot of those different consortium, but they're not all knowing about each other. And I think a meeting like this today will help us bring us all together and learn from what we have what we have done in the past. And then make people feel included. I think that's also what we're trying to achieve by meetings like this, but also through the communication in the Slack channel, for example. If new people are joining, that we welcome them, that we ask them about what they want, stuff like this, and that we really appreciate people that join. Code of conduct, that's also what Amos mentioned. We have that already. And I think one of the last points that I wanted to make, what's also a great step to get people involved, is to make the deployment a little bit easier, or to help people set it up and get started. And so there we heard already from yours about Radar Kubernetes this morning. And I think there's also something that we as the Hive, for example, offer, that we can host it and maintain it for certain studies. And then we can provide training and help you get started. And so for Kubernetes, I'm not going to go into that. Just going to say that it's lightweight and easy to install. It's probably didn't look like this morning, but it's definitely, it helps with the transparency and it helps with reusability. So it's definitely a good step in the right direction. It's still not really easy, but I think it helps you to get started if you really want to invest in looking into that. And then the other way that I also just mentioned is that it can be also hosted for you. So what we need to do then is really understand the protocols and the study needs. So we start then with requirements gathering workshops. We understand what data you want to collect about for how long. And you can just, get an instance of Radarbase where you can try it out. So where you can start a pilot, you can collect data from a couple of participants, analyze it, see if it makes sense for you, and then just continue and have a possibility to scale up, of course. And then so we come to the roadmap. We don't have a document that is the roadmap, but I think what I wanted to do together with you is to think a little bit about it. What do you think are really the crucial points? Where do we need to do something? And I know it's late in the afternoon, but I think it would be really helpful to get some pointers from the audience here. So is there something that you think, okay, this is really missing, or that I would really like to see in the platform to improve it, or to make my study easier, for example? I think maybe if nobody says something, I'm just going to point out people, because I think, Simon, this morning you mentioned FAIR, for example, and the way of findability of studies and data. Is that something that you think would help a lot, or?
It was just out of interest. I don't think it would help. I don't think it help a lot, but I think as the question was answered, not all data is there to be shared, but some data is, and therefore being able to plug into the existing catalogues, that's a natural roadmap thing. Not everyone here would care about it, but it's one of those things that somebody could contribute for sure.
Yeah. And I think we were also thinking at a certain point to have some sort of data set that people can use based on the data that we have already. So just anonymized data, but where people can try out their algorithms and stuff like this. So maybe that would be potentially a nice thing to have.
For me, the best thing would be a demo site that wiped itself on a weekend and came back alive or whatever. We've been trying for a while to install it, given up, it's too hard. But it's kind of, if there was a demo site, we could kick the tires and give it a go and try it out and then decide whether we're going to invest in that install or not bother. I think that would really help.
Thanks. Paul, in the back.
So just to add on the fair data bit, You may or may not know there's a kind of a key European policy called the European Health Data Space, which is coming down the line, probably about 2 years or so. It'll take a while to get there. But when it's in place, one of the requirements for Europeanly funded projects is that they make their health data available to this European Health Data Space. So thinking about the standards and all that type of thing, which would feed into that, probably something you could think about already.
Yeah, thanks. And I think that's a good point that you're raising. I think the data standards or the common data models for wearable data and sensor data, that's something that we're also still looking into. And I think there's not too many standardization yet. So I think this is also something that where we can, have some impact with all the different data sources and data streams that we collect. Okay, and maybe just one other thing, the dashboards that were mentioned, I think, Will, you mentioned them this morning. What would help you as a clinician, for example, for a clinician dashboard?
Well, I think for clinicians, the key thing is that you don't have to log into a separate system, because clinicians often have no time to do extra things. So if you have to log on to a separate system and authenticate as who you say you are and find the right patient, you've already used up 5 minutes of your 10-minute consultation time. So integration into usual workflows and into EHRs it can help with that, but that's not an easy thing to do.
Yeah, indeed. We looked into that, and it's really seems to be really tricky to add anything to a hospital system from the outside. I think that's one of the bottlenecks. He always looks at me and goes like, "I'm not sure. Do you want to make a comment?"
I think yours was right. Yeah. So a lot of this comes down to documentation, which is really dull compared to building it. How do we fund documentation? Because even the dashboard element, Grafana is really easy to use, and our time series database is fantastic. You can do anything in the world, but if you've never seen anyone do it, and so therefore if someone doesn't fund a set of videos or documentation about these are 4 or 5 use cases, watch this, and you'll be able to do it yourself. Somehow this bigger ecosystem needs to find a funding stream to kind of fill that real gap.
Yeah. Yeah, no, that's also a good point. I think that's probably also where we could use some of the dissemination budgets and all the projects probably to do that, because I think that's a big step to really make sure that, that it's going to be sustainable what you build, because otherwise we have the platform, but if people don't know how to use it, and at a certain point we're all going to not work on it anymore, then there's nobody who can take that up. So that's definitely a crucial point also, yeah.
I mean, making the installation sort of tractable for, I wouldn't say anybody. I think that's unrealistic. It's a very complicated thing inherently. But yeah, making it sort of tractable, I think, was our kind of first rung on the ladder, and a lot of the kind of efforts, which started about 3 years ago, to sort of make the kind of Kubernetes deployment kind of viable, was sort of the first step along the line there, so people could at least get a development environment spun up on something like K3S pretty easily. That's kind of there now, but previous to that, we were still sort of struggling with a little bit, how to kind of get that.
Could I just come back to the point about data sharing? So we want data to be findable. There's going to be an increasing requirement of funders that as you run a study, then that data should be shared with others. But it makes it more complicated for the participant, and it changes the governance. So incorporating into the consent the willingness to share on with others, there are trust issues when patients sign up to that, but one way around that is to provide feedback to the participants as to who's touched their data. So I guess in a roadmap, kind of considering how you enable a feedback mechanism to the participant, not just about their own data, but what's happened to their data subsequently, may be worth thinking about.
Yeah, I think that's also something that we can take up, because I think the consent is, of course, one of the things that's difficult and stays difficult, but there's definitely ways that we have to think about it.
That's one more question. Have you done any UX persona review
of who would use the system. I think it's one of those things where it evolved from one place, and people, I've seen you now field many questions of people thinking about its purpose as being for maybe a different set of stakeholders. So I'm wondering if you've done any sort of user experience persona analysis on it, because it seems like it's one of those things where it could go in a whole bunch of directions, in terms of roadmap.
Yeah, I think we have not done that, but it's definitely a good point. But what we see for different studies, you have different audience, and we see people want different things. So, for example, if you have diabetes, there are people that want to see the data, but there are also people that don't want to see that, and they don't want to compare it with other people. And so it's really difficult. It's not difficult, but I think it has to be on a case-by-case basis. Who's the audience? With whom, do you want to do your study, and do you want to show them something that would, somehow intervene, or do you just want to have an observatory study where you just collect the data? So I think it really has to be somehow on a case-by-case basis, I would say. But then it also helps if we have some more modular dashboards, for example, where you can grab, the aspects that you want and show them, for example. Okay, but so I think that's really helpful. We're going to collect them, we'll put them on the roadmap, and I really would like to encourage you to also use all the channels that Amos has showed to really provide also ideas if you have them, because I think this is also one of the main goals of this, bringing us all together to really find out what are the features that most people are missing, and can we, put up together to make it work, and think about it, how we want to integrate this. Thanks for that, and then I think it's time for coffee.
Yeah, maybe let's be back at 4:20, and please remember to scan the app download the app, scan the QR code, and vote. And we are going to take a picture now here before we go. So if you don't mind, just coming to the front, and we very quickly take a picture before the coffee.
Gonna have big smiles. You guys want to make like a fun pose? I know everyone just really wants to get coffee, but give it a try. One from down here. Thank you.
Thank you.
asked everybody who was a stakeholder what features of the show. And then we found out that 80% of them we were never going to be able to do.
Yes.
And so we positioned them. Yeah, exactly. Yep. So, your management portal supports ours doesn't. If you want any of that, then obviously it'll be very old. So far, what we've done, like I might be your stakeholder. As I said, I could roll up a management portal into my office. I'm on clusters. If we want 15 deployments, we just spin up 15.
Yeah, it has been done.
Next cluster. We're not in the cloud. No, yeah. Well, today. Next year, we're starting to do sub-studies. Sure.
Sure. I mean, I knew.
Yeah, use cases. Yeah, right.
You want to put like 6 hours of course over work on it. Because the nature of this is it'll be busy.
Yeah, I've definitely heard of it. I mean, I've just not been. And actually, yourself and Paul
Definitely not that bad. It used to be bad because it would run output generation once per hour, then once per hour it just and now it's quite continuous. So
maybe now it's
not that bursty.
yeah, I'm just going to say.
Also, I think you could reuse some stuff as well, like install Prometheus if you have a Prometheus instance. Might as well.
Okay.
Listen, you want? I can take another nice one right now before you. I know, I'm sorry, I'm still getting a hang of the camera. I'm not a professional photographer. Maybe one photo session I can put. Okay, so there's 2 cameras as well, so this one will get like the whole thing, and then like close-ups of your faces.
I don't know, but I want something similar to it.
Yeah.
Okay. Like I'm talking, but I don't have
You can be lecturing me about how you are upset at work. Okay.
But anyway. Yeah, that's enough.
I got 10 pictures here. See, with this one, I'm not able to figure out the lighting. That's the biggest issue I'm having. So, like, the light comes and goes.
My hair looks happy.
Okay, we can do this again. Oh, I got it this time. Yes, that makes the light better. Okay. Okay, let's go. You want to hold the mic? Okay, yeah.
Oh, just because I don't know if I don't have to.
Yes. Okay, got it?
So this is how I was in the morning?
Yes.
I don't know.
Yes, just.
Yeah,
You can,
no,
you can.
this looks silly.
Very good.
Well, I need to find
I'm sorry. I tried my best.
It's okay.
My best wasn't hard enough. Oh.
Yeah, I'm also probably going to change my shoes. I need to run.
Yes.
Like one.
Are you getting a cab or do you take the
I'm taking the public. Okay, takes long.
You emptied out all those goodie bags, no? You're not taking them back. All right, safe trip. Bye. Are they all high school?
Well, yeah, we weren't sure right off
It's a using that data. The moment we start pivoting towards object data, less engaged population, so the second piece was really this is a lot harder.
Okay, hello everyone. We are almost done. I just want to remind you to all vote because we are going to use the questionnaires. Is everyone, if you haven't done it yet, you have 5 minutes. So please go ahead. And we are going to just continue with the last talk, and then we will award the prizes. And as we mentioned, we go for networking drills afterwards, and Amos and Richard will give instructions later on how to get there. Running out of batteries. Oh man, we don't have batteries anywhere. Where is the
Testing.
Right now, the network contract with data
yeah, the other one we took it. I'm gonna pick it up. Okay,
here, so like checking yeah, not good. Not do that. So, okay.
Hi there. So, well, welcome to our last session of the day. This is going to be a slightly different talk. This is not anything to do with the Radar CNS project. This will be from Callum, who's a PhD student in Richard Dobson's group, and his research is primarily focused on personalized modeling with remote monitoring studies, namely in stress, seizure detection, mental health, and COVID-19 monitoring. So he's going to do a talk today on COVID Colab, remote monitoring setup, started in 2020 to observe the effects of COVID-19 through participants' donated phone and wearable data. The study makes use of a modularity of the radar-based platform, using some custom-built components alongside pieces of the radar base.
Thanks. Yeah, as Amos said, it's a talk on COVID Colab, which is a study that we've been running for like a year and a half now, I guess. Basically set up in around June 2020. And the idea was to get people to, just like any member of the public would be able to sign up and sort of donate their wearable data and fill in some questionnaires sort of similar in style to like the Radar CNS studies in content, but yeah, just open for a sort of free-for-all recruitment. So in total, as of like around now, there's there have been around 17,000 people signing up, so it's did okay in the end. But yeah, so I'm gonna talk about like the sort of a little bit about the technical background and the app and how it ties into Radarbase and that sort of thing. And then in the second section, I'll talk a little bit more about some long COVID analysis and looking at current work that we're doing to look at sort of long COVID through things like Fitbit and mental health questionnaires. So, the two parts. The study app was like custom built rather than using the existing Radarbase ones, just because we needed a few like bits of functionality which weren't there. So like remote enrollment, at least at the time wasn't, and yeah, mostly that. And we wanted to include elements of the PRMT data collection or passive data in the same app. So ultimately, that didn't come to too much because Google eventually decided that we weren't allowed to collect location. So, and then the backend is partially using sort of Google Cloud services for things like account authentication and for sort of some of the initial like survey collection in Firebase, and then we use Radarbase to, well, it's tied to the accounts in the Google Cloud, and we use the sort of the Radarbase to pull in data from Garmin and Fitbit, essentially. So using that REST connector that was developed in Radar. The app is like some pictures there, but basically it's very similar in functionality to like the passive app. Oh, sorry, the active app. It's, you know, it's got like a similar sort of, in fact, it uses the same questionnaire definitions for like the mental health scales, for example, and it displays them in a similar way. It's basically just got an addition, the ability to enroll through it, so it's got like an enrollment and consent flow. It's got a little history screen, which was, the idea was some sort of participant engagement or to make them want to use the app more. They'd be able to see some of their own data. And the ability to connect your Garmin or Fitbit device. Or, you know, yeah. The backend, as I mentioned, is mostly like Google Cloud for things like authentication and initial collection. And then, yeah, this is basically just a visualization of what I've just said. It may be quite small to see from the back, but so our initial like aims for the study are really just to set up this sort of crowdsourced initiative and use that wearable data to do things like identify risk groups or factors that would put people at risk for COVID, like on account of socio-demographic data. Do things like try and use machine learning to detect or predict disease states, so whether someone has COVID or not, for instance. And also, we collected PHQ-8 and GAD-7 surveys throughout. And so we wanted to see the effect of both COVID-19 and the sort of public health and social measures implemented throughout the pandemic, and see what effect they had on depression and anxiety scores. Originally, obviously, we didn't know about that long COVID was really something to, well, we didn't, that it existed. And so, you know, subsequently, this is one of the things that we've adapted to a little bit, to look more into long COVID. I mean, similar sort of aims again, but basically, since we have this sort of existing study that we've collected throughout the pandemic, it's in some ways nicer than trying to start a study on long COVID from scratch once you already know about it. So the dataset or the protocol, these are the things that we collect. Basically, the PHQ-8 and GAD-7, and then just some COVID-specific questionnaires on things like symptoms and whether they've been diagnosed, whether they've had vaccination, etc. And then on the active side, we collect Garmin and Fitbit, although Garmin was added much later, so is nearly all Fitbit data essentially. Originally, we also collected like raw location data, which could have some like potentially interesting things in that you're able to look more at the context of the location, so you can know exactly where we were or what sort of areas we were in, for instance. But although we do have a fair amount of location data from the early study, obviously that was discontinued after around December of last year, or sorry, of 2020. There was only like maybe half a year's worth of that. This will probably be very familiar to people working in, radar-based, but there's like different frequencies and various levels of missingness for this sort of data. And I think that's probably compounded in a study like COVID CoLab where it's remotely enrolled and with very little contact with participants. We don't have any, researchers directly talking to people or trying to recruit them. It's really very a self-motivated study, which obviously has implications for things like retention and how much people can be bothered to continue. What you do see is that some people are very self-motivated and are able to complete things very often, or essentially, twice a week when they're asked to. Other people will manage to connect their Fitbit and maybe fill in a couple of surveys and then they'll drop out of the study. And, obviously there's a range between that. Since a lot of what we look at is more like the passive, or what I've looked at least, is more of the passive data, and with respect to a COVID diagnosis, it's actually still fairly useful just if they're able to tell you when they were ill and give you access to their Fitbit data. That's already, a substantial donation on their part, a useful one. And passive data tends to be more complete. It can obviously, depending on how much a person wears it and so on, be various levels of missingness, but it tends to be fairly good. And we collect it also from basically the entire history that they have available, not only from just the start of the point that they enrolled. So you have a good baseline set of data going back, in some cases, several years. So moving on to the long COVID or analysis. Basically, we've got mostly what I've looked at so far has been the passive data, the Fitbit data, so things like the heart rate and the sleep, and movement or steps following a COVID infection, and seeing what effect there is, or if we can in some way define, I don't know, just to see long-term effects of COVID in these particular metrics. We also have obviously self-reported symptoms following COVID. So that is another way to define long COVID with respect to our data. But I think there's it would be useful to be able to say whether someone is likely to have, long COVID or persistent symptoms on the basis of their passive data. Because a lot of people, especially in our study, will have dropped out or, following at some point in the weeks after they've enrolled, or they just won't have consistently input symptoms and so on, or they won't even necessarily recognize that they have long COVID necessarily. So the idea is to look at, firstly, at group-wide differences. So just looking at points of time, say 10 weeks after a diagnosis to people with, are there still differences in the passive metrics, 10 weeks following a diagnosis of COVID in those COVID positive group compared to a control group, who we define as basically participants who have been active in the study by filling in questionnaires and so on, but haven't haven't reported a diagnosis prior to that point. Then the second point was trying to figure out the duration of symptoms with respect to things like heart rate. So when you look at something, say 10 weeks after an event, and say there's a difference, which like some studies have done, and there is like a significant difference between groups, for example, but you can't say much for an individual because there are various reasons that, your heart rate might be slightly higher 10 weeks after something has maybe happened to you. So I was looking for methods that would say whether or not there was a change that occurred basically coincidental or at the same time as the COVID diagnosis, and then how long that change stayed, and time period before a return to some sort of baseline. So the group-wide differences, these are just some lots of like the different metrics. On the left is just the relative difference in heart rate, sort of averaged over a group, and on the right is the proportion of people with a 10% increase in heart rate compared to the baseline, or where the baseline is defined as a fortnight or 2 weeks prior to the infection, essentially the average heart rate throughout that period. And these are all resting heart rates as derived from Fitbit or given by Fitbit, so they're the sort of nighttime resting heart rate that Fitbit provides. Although we do have access to the intraday data as well. And so yeah, basically for heart rate, there's on the x-axis there's the number of days, and the blue line is the diagnosis date, I should say. And so at least on a group-wide level, you can see that there's some sort of persistent increase in heart rate that lasts for a fairly long time. But the actual proportional effect isn't massive for the group-wide, looking at it as an entire group. The steps, obviously there's a pretty big decrease, as you might expect, once you're diagnosed with COVID, but it fairly quickly returns, or after several weeks it returns to basically the same level. And sleep it's sleep efficiency, which is just a metric provided by Fitbit, and that does have a small decrease, but it's not a very significant change, which is in some ways surprising, since one of the longer term effects is like fatigue. Or can go on to that later. Okay, then for mental health, on the left again is just like the average PHQ-8 score, and on the right is the proportion of participants with a score over 10. And so basically there is again a sort of kind of fairly long term, this only goes forward 80 days, but there is an increase in the average score, and maybe 5 to 10% of people appear to have persistent sort of higher scores after diagnosis compared to prior. Well, the areas are quite high, but quite wide, but there does seem to be some sort of effect. When anxiety is, there's a less clear effect, I suppose, but following a similar pattern. In addition, we also asked for self-rated valence and arousal scores. This was basically prompted for twice a week, and it was a slight sort of just an alternative way of looking at happiness and sleepiness on sort of a quicker interval than the PHQ-8 and GAD-7 and other mental health questionnaires that we were using. But yeah, it essentially shows a similar story. The arousal does have there's again like a 10% increase, or 10% of people with COVID have negative arousal ratings for like a long period of time following a COVID diagnosis, which is maybe sort of what you might expect given that like one of the known symptoms of long COVID and one of the most common is fatigue. So people self-rating their like arousal score negatively is maybe expected in that case if they were fatigued. And then, you can't actually see the bottom right, which has some writing in. But if you compare like the distributions of the control and COVID positive groups at this 10-week differences for the different metrics, and here is like heart rate as an example. Usually you do see like significant differences between the two groups. And you can probably see, so on the graph, for example, there appears to be kind of two peaks, whereas the COVID positive group had like maybe a sort of peak here and another separate one, which is similar to the control group, and then another peak here, which is slightly to the right, which possibly corresponds to two different, long COVID or non-long COVID groups. It's hard to tell. So yeah, just to like summarize that, basically all modalities there is some sort of acute response, not all. So the main ones for looking at long-term or where there are clear long-term effects of things like heart rate and for mental health or depressive symptoms and maybe arousal are the sort of three main ones where you can see long-term group effects. There are like some problems with looking at just like comparing a baseline reading from a few weeks before a diagnosis to 10 weeks post-diagnosis. So, for example, there are like seasonal differences in things like heart rate or sleep, time spent asleep and so on, or depression, PHQ-8 scores, I assume, seasonal differences. And given that most diagnoses has happened at particular times, for example, the second wave in December, or basically most people are diagnosed at 1 or 2 times in the second or third wave, and so seasonal effects could explain some of the difference potentially. There's also a lot of variance in some people's data. Some people have quite low variance heart rate, for example, but other people have quite high variance, like over weeks, and so if you just happen to take a week in which they have a relatively low heart rate and then compare it 10 weeks past where they just happen to have slightly higher, you could, say that person could have long COVID, but in fact it's just where they've got a fairly variable heart rate. Or that a person has had some other intervention or reason to have a higher heart rate in those 10 weeks. For example, maybe maybe it's starting to become brighter outside and they start exercising more, going outside more, and that has an effect. So to address those things, firstly, basically I want to be able to say that the change happened at the point that they were diagnosed with COVID, and that change has persisted for the period of time up until it was, for example, it persists for 10 weeks, for example, or to be able to say how long a change persists for each person. That has some potential problems because, like a lot of diseases, there are periods of remission and relapse in long COVID. However, I think just as a sort of simple way of looking at it is okay. So basically, the first thing I did was look at structural break detection. So essentially, I fit like a ARIMA model to the data prior and post diagnosis, and then calculated a Chow statistic, which basically tells you the probability that the two models are the same or have the same coefficients, which is used kind of like in econometrics a lot for basically structural break detection or change point detection. So if you do that and you calculate how many people will have a structural break at that point, then around 6% of people, for example, for heart rate, have according to this method, a significantly different heart rate in some way. That's like corrected for like multiple testing with the Olmsted method. You can see also that the majority of people appear to have a higher heart rate for, well, you can't quite see actually because I'm in the way, but there's a greater proportion of people seem to have an increase in heart rate, but there are also some people who have a lower heart rate following COVID infection. The sleep and fatigue. So the sleep duration at least didn't seem to be particularly like significantly changed following a infection between the two groups. If you look, at least when comparing groups, but if you, a small number, maybe like 2% of people, according to this method, have a structural break in their sleep duration, which is the point here, though, I think, is that there doesn't seem to be a large effect in sleep quality or duration, but there is definitely a large increase in people like reporting negative arousal scores or like that they're more fatigued. And so it's possible that the fatigue is not caused by disturbed sleep, but just for some other reason, basically. And the second thing that I was doing is using Bayesian structural time series models to like predict a time series following infection as if like on the basis of a person's data up until the point of infection where they're infected with COVID, you fit a model and then use that model to predict the future would have happened had they not been infected. And then you compare that prediction to what actually happened and use that to say how strong the effect was. Uses the causal impact library, which Google developed, I think, mostly to look at the impact of internet advertising, but using it here for COVID. Maybe, some pictures. The advantage of this is, in comparison to, say, just taking the mean, is you can fit different things like seasonality into the model, and you can have confidence bounds, for example, for your prediction. So these are two different people who one person has like an increase in heart rate of during the acute phase of like 10 to 15 beats per minute, and then that takes around 90 days to return to the mean of the prediction. There are only like several weeks to return to the confidence bounds. And then on the bottom, which you can't see as well, but it's similar story in reverse, and where they have a much reduced heart rate. And I guess the point here is that, at least in the papers that I've read, from studies doing similar things, usually they have only looked at an increase in heart rate, or they haven't they've sort of they've, for example, split it. They've said what proportion of this group has a beats per minute increase of over 5-10 weeks post-infection, and in that case, you potentially miss people who have had whose heart rate, for example, has changed, but not in the way that you've assumed would happen. So that's one of the benefits of not making an assumption in that way. There are also people with less clear changes to their heart rate. So this person has a very large peak when they're first diagnosed, but followed by a slight dip and then some sort of return to mean. This person doesn't appear to have long-term effects, but it was an example of that. It's not always just one way or the other. In fact, if you look at the group-wide heart rate, it has an initial increase, but then a small dip, because actually a lot of people seem to have an acute, or a fair number of people have an increase in heart rate during the acute phase, and another set of people have actually quite a big decline in heart rate. So for that reason as well, we're looking at it at a group-wide level. Just the mean change isn't ideal. So in summary, depending on the metric, maybe 2 to 10% of people seem to have long-term effects that we can measure through Fitbits. Looking to the future, basically we want to use, for example, these models to estimate a time to return to the baseline or time to return to a healthy state, and then use that to find predictors for the time to recovery from things like sociodemographics. Potentially looking at different models for the time series prediction as well. Thanks.
Thanks, Callum. Is that on? Yeah. Really elegant and nice to see. I mean, I'm not sure if I caught it. How many actual COVID cases did you have in the 20,000 odd participants, do you think?
I don't think I did put that in. Well, I think it used to be in, but maybe I removed it at some point. So I think the number of reports is somewhere 2,000-ish, but obviously not all of those people have the data you want for the particular thing that you're looking at. So they don't all have Fitbit data, and when they do, they don't always have Fitbit data for the period that you want to look at. And so I'm sure you know the...
Okay. And there'll be challenges in terms of case definition of COVID as well, because some will have...
Yeah.
Some will have antigen, some won't, depending on the time when it was done and so on. But really interesting. So I guess one of the questions I'd be really fascinated by is the pre-COVID. So if you're predicting effectively long COVID, there's a big kind of area in the literature about pre-morbid kind of fitness, effectively. And, the story of a lot of the cases is often sort of super fit people who crash and are never the same again. So it'd be really interesting to be able to look at the heart rate data from before.
Yeah, I think that's one of the maybe advantages that we have is to be able to look at passive data from a long period of time and to quantify sort of how fit someone is or how active they are.
And just, sorry, one last thing. How many people think they've got long, or say they've got long COVID?
We don't really specifically ask for it, or I think we added a long COVID questionnaire or questions at some point, but we don't specifically say, do you have long COVID? We asked for like symptoms and COVID diagnosis itself.
Thanks very much.
Yeah, really nice, Callum. Thanks. Just a curiosity about the heart rate. Do you use the 24 hours average?
And it's the one that's provided by Fitbit as the resting heart rate, which is taken during the night, I believe. Not exactly sure how they calculate it, but I think it's basically just an average of heart rate while they're asleep, as far as I know. Maybe other people will know more about how Fitbit calculate it. But.
Nice. Just because I was wondering this opposite, the fact that you see it's either an increase or a decrease. I'm wondering if the decrease is because, a lot of people that have a Fitbit use it because they train a lot. So maybe the decrease is because they didn't do their usual exercise and their average heart rate could decrease because of that. Do you know if anybody investigated that? Or maybe if using the heart rate only during the night or when the accelerometer is not active, something like that could...
Yeah, well, like I say, I think that it is supposed to be calculated mostly or entirely at night, this resting heart rate thing. But I think in the future it would be good to, because we do have the intraday data as well, I just haven't used it in this particular work. So I think, to ensure that it is just during periods that that won't be a factor. So, yeah,
right.
We could do that.
Yeah. Nice, thanks.
I was just going to say the same, that it's important to know if when you were computing the mean heart rate, you were considering just resting periods or the whole day. Because if not, the activity level that is changed because of COVID could mislead the interpretation that you have.
Do we